Welcome back to the Foundry by Forge College. In this explainer, we are tackling automating Solana workflows with CI/CD. Now, if you were with us for the last module on Git workflows for toolchain integration, you know we got things running really nicely on your local machine. But it's time to take off the training wheels. Today, we're upgrading from that artisanal, handcrafted checking process and building a ruthless, highly efficient automated factory for your Solana developments.
Here is our blueprint for today. We're looking at 1. Beyond local Git hooks. 2. Designing your CI pipeline. 3. The automation script. 4. Verifying pipeline logs. And 5. Debugging CI failures. Let's get right into it.
Section 1. Beyond local Git hooks. Scaling toolchain checks.
So look, we've all absolutely been there, right? A developer pushes some code, the whole build breaks, and they just throw their hands up and say, well, it works on my machine. Now, a local Git hook is great, but it's basically a security guard standing at your own front door. It only protects your specific laptop. A CI pipeline, on the other hand, that is a standardized factory checkpoint. It runs on every single pull request, meaning absolutely no code is going to bypass validation just because of some weird, unique caching quirk on your local setup. To make that global checkpoint actually reliable, we rely on a deterministic script. Now, deterministic is just a fancy engineering term that means the script executes the exact same way and spits out the exact same results every single time, even when it runs on a completely temporary blank slate cloud runner. So no surprises and definitely no random ghost-in-the-machine behaviors.
Section 2. Designing your CI pipeline. Build the assembly line. Think of the logical flow of our new assembly line here. First up, checkout. That's retrieving your code. Second is toolchain setup, where we install the Solana tools. Third, build, compiling your on-chain program. Fourth, validate, which means running your static checks and tests. And finally, artifact, capturing those resulting binaries and logs. It's a perfectly structured sequence. And that final artifact stage, it is absolutely crucial. Artifact versioning ensures that every single pass or fail leaves a permanent auditable paper trail. If your code passes, boom, you've got a ready-to-go binary. If it fails, you have the exact text log safely stored away. It literally removes all the guesswork from debugging later on. Section 3. The automation script, powering the pipeline. All right, to actually power those pipeline stages, we need an engine. You're going to create a small, highly portable bash script. Usually we name it check Solana toolchain.sh, and you drop it right in a .ci folder at the root of your repo. This script runs the exact same validation commands you used in your local hook, but now it's standardized for the cloud. It's totally testable, repeatable, and securely locked into version control. Now, a massive part of this script's job is enforcing what we call a toolchain pin. Basically, you are hard-coding a specific version of a software tool, like Solana 1.14.0. Why? Because this completely stops the CI runner from just grabbing the absolute latest unstable release and randomly blowing up your perfectly good build. You want total consistency across all machines. Because of this, your script has to be incredibly defensive. It must pin the toolchain, install the Solana CLI if it's missing, explicitly print the version to your logs, build the program, run unit tests, and, this is key, it must exit with a non-zero status code instantly upon any failure. If a single dependency is missing, it hits the emergency stop button. And hey, here's a modern vibe coding tip for you. You really don't have to write the entire pipeline wrapper from scratch. Because let's be honest, writing boilerplate YAML is nobody's idea of a good time. You can actually feed an AI assistant this exact prompt to rapidly scaffold out your initial GitHub Actions job. It gets you straight to testing your actual logic way faster. Moving to Section 4, verifying pipeline logs. Check job execution. Now we arrive at the million-dollar question. What actually happens when the pipeline fails? Because we really need to know exactly how the system reacts when a bad piece of code tries to sneak its way through our pristine new assembly line. Remember how we configured our script to exit on the very first error? Well, because of that, the job performs what we call a fail fast. It instantly blocks the pull request, turns the status check bright red, and saves everyone a ton of time. I mean, nobody wants to wait for a 30-minute build to finish just to find out there was a silly typo way back in step 2, right? And finally, Section 5. Debugging CI failures, fixing the machinery. When those inevitable failures do happen, you're going to see a few usual suspects. See a command not found for Solana? That means the runner lacked the CLI, so you need to add an explicit install step. Getting a missing crate error? That's probably a Rust version mismatch, which means you need to pin your Rust toolchain. Random timeouts? That's usually a network failure, so just add retries. The point is, we have to explicitly instruct the runner because we simply cannot rely on cached, local setups anymore.
If you take one golden rule away from this whole explainer, let it be this. Treat CI as your canonical, reproducible execution environment. It is the single source of truth. As you dive into more continuous learning programs with Forge College, always remember that the CI environment is the ultimate judge. If it doesn't pass in CI, it simply doesn't pass. End of story.
So the big question I want to leave you with, is your automation truly bulletproof? Well, we are going to put that to the test in our next lesson with some actual broken pipeline runs. But for now, you've got the tools to start building a highly effective CI/CD pipeline for Solana. Make sure to head over to forge.college to learn more about the subject and explore a ton of other fascinating Web3 topics. Thanks for learning with the Foundry by Forge College, and I'll catch you in the next explainer.